All right, so guys, yeah, we're going to start talking in 5.1 a lot about sample spaces and probability, and you guys kind of have an idea there, all right? How about the probability that it gets to 80 degrees outside today? Pretty low, right? Okay. What's the probability you're going to get out of here at 2:15 today? Pretty high. Okay, so you guys have some pretty good background in probabilities today. So in 5.1, titled Sample Spaces and Probability, here's a question we're trying to answer. So how about I volunteer to read my essential question here today? Go ahead, Frizz.
How can you list the possible outcomes in the sample space of an experiment?
Okay, so we're going to talk about how to list outcomes in what's called a sample space, all right? So in order to answer the question, these are the goals we need to accomplish. First of all, we need to do what here, kids?
Find sample spaces.
Find sample spaces. Theoretical probabilities. Find experimental probabilities. And then one that kids struggle with a lot, finding odds of something, okay? All right, so let's make sure we understand all our vocabulary before we progress through this. So there's a lot of it today, so we're going to read through this. I'll give you some examples of what it is over there. But kids that are new in here, the notes that I have up here, same thing for you. Anytime I write something down, I strongly encourage you to get that down, okay? All right, probability experiment. A probability experiment is an action or a trial that has varying results, okay? It's kind of like flipping a coin. What are your possible results? Heads or tails, okay? So a probability experiment is something that happens when there's maybe a different result that comes out. Rolling a die is an example. Spinning a spinner, okay? Let's see, if I do a backflip, what are the possibilities?
Break your neck.
Pretty
Break
slow.
my neck.
Laying on your feet.
Laying on my feet. How many think I'd break my neck if I did it?
You probably just get a concussion.
You probably hit the roof. I honestly think you'd hit the roof.
Oh yeah.
Possibly, okay? If I tried to do a backflip, is that a probability experiment?
Yes.
Yeah, something's going to happen. Don't know what. Probably not going to end well for me. Okay, but a probability experiment is an action or trial that has varying results. Kind of like flipping a what? Flipping a coin.
Yes.
Flipping a coin would be an example. Okay? All right, then the outcome. The outcome is the possible results of a probability experiment. They're called outcomes. If we're using that flipping a coin as something that's probability, what are your possible outcomes, kids? I always say heads or tails. I always say there's three possibilities, but because it could land standing straight up, couldn't it?
All the time I told you.
Right? It could, couldn't it?
Yeah.
Okay.
Chance.
By the way, does anybody ever know why tails never fails? Let's say, you know that.
Weighted.
Yeah, center of gravity is not right in the very middle. So the center of actually the head's part is higher up. There's more mass towards the head side. So gravity acts on more mass, so the head side always wants to land down because that's what gravity tends to do is pull up more mass. So which side lands up most times?
Tails.
Because there's, the center of gravity is closer to the head side.
So this is like
Okay. All right. An event. An event right here is a collection of one or more outcomes. It's called an event, such as rolling an odd number. Okay. So the way that we write events right here, sometimes we say, what's the probability that you get a heads? And they write it kind of like this. They kind of like say, what's the probability? They put your event that you want to have happen here in parentheses. So when I say, what event am I after? We're looking for the probability that we flip what here, kids? Heads. Now again, I know that you've talked about some of this stuff in the past, but things are going to get kind of complicated as we go through this here. We're going to start looking at not just one flip, but we're going to be looking at multiple flips and see what our possibilities for things are, okay? And I think that one term that's really important in here is this one right here. Sample space, okay? How about I volunteer to read that one for me?
I will.
Go ahead.
The sample space of an experiment is the set of all possible outcomes for that experiment.
Okay, so when we talk about this right here, if I say I'm going to flip a coin once, well, we know that there's how many outcomes? 2, okay? But what we're going to start looking at is possible outcomes for saying, not just flipping a coin once, but maybe we're going to flip it 5 times or 6 times, okay? So a sample space is going to be based on sometimes it's based on multiple trials sometimes, okay? And we'll look at some examples right here, but just understand this. Sample space doesn't mean, ooh, I flipped a coin, it's either heads or tails, that's it. It wants to talk about what are your possible outcomes when you flip that coin 3 or 4 times, okay? And then they want you to put some order to it. Because you might get heads, heads, tails, or heads, tails, heads, or tails, 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 or you understand what I'm saying there? Okay, so we're talking about multiple trials right there. Okay. Next one right here, probability of an event. This is pretty simple, and you guys were talking about this really well at the beginning. So the probability of an event is a measure or the likelihood or chance that an event will occur. Probability is a number from what to what, kids? Including 0 and 1, and can be expressed as a decimal, fraction, or percent. Okay, the thing I want you to understand is this. If something has a 0 probability, what's that mean?
It's not gonna happen.
It's not happening. It is
Possible.
impossible. Okay, 0 means impossible. Anybody know the word you attach to? There's a probability of 1 that this is going to happen.
Improbable.
Probable.
Not probable. It's actually, they say,
It's going to happen.
definitely going to happen, or sometimes they use the word, it's certain. It's going to happen. Okay? I would never say the probability of the Vikings winning a Super Bowl is 1. Okay? Even though I'm a fan.
Because it's trash.
Oh, Michael, we're recording.
Yeah.
Mr. Mike, just remember, I can change your schedule at any time.
Oh, no. I can't go back. I can't go back.
Would you like to rescind your statement?
Yeah.
Thank you. All right. Theoretical probability. Okay? No, it's not a threat. It's just a fact. Okay? But hey, we don't talk about facts in this day and age anymore. When all outcomes are equally likely for theoretical probability. So like we say flipping a coin, we say the probability that you get heads is what? 50, and the probability you get tails is also what? 50. The outcomes are equal. If I roll a die, the outcome for each value or each face, what's the probability of rolling a value on a die? 1/6. But each one has the same equal chance here. We say theoretical probability is when all outcomes are equally likely. The theoretical probability of the event can be found using the following right here. Theoretical probability is equal to what over what, kids?
Number of favorable outcomes.
Yep. Theoretical probability. There you go. Okay. So if I say right here, if I use this idea of getting heads, what is the probability on one flip that you get heads? Well, kids, number of favorable outcomes means this. How many sides are heads on that? 1. How many possible outcomes are there on that coin?
2.
Okay, so there's a 1 in 2 chance. Okay. Now, experimental probability is something that's based on an experiment. Okay. Let's say I flipped that coin 60 times, and 59 times it landed heads. Now, theoretically, on the 61st flip, should be 1 in 2 chance that I get heads. But how many times have I gotten heads in 60 flips? 59. So it would say the experimental probability on the next flip would be 59 out of 60. Okay, experimental probability is something that's based on repeated trials. It's based on what has already happened. Okay, we talk about experimental probability based on what's happened already. Did I spell that right?
What?
Yeah, I did, didn't I?
I think we're at it.
Yeah. Okay.
Yeah.
All right, so vocab-wise, let's keep rolling through this, and then we'll try and get through this. By the way, what time are we out here today? 58. Okay. Anybody need more time? First page right there. All y'all good?
Yeah.
Okay. Next page here. Some more vocab, and then we'll start running through some examples. Okay. Again, we're kind of finishing up with this experimental probability. It says the number of trials is the number of times the probability is performed. Each trial which a favorable outcome occurs is called a success. The experimental probability can be found by using the following. Experimental probability equals number of what, kids?
Success.
Number of successes over the number of... Where are my basketball players in here? Okay, TJ. Free throws in basketball, right? Part of the game. Let's say TJ on the season shot 24 free throws. Let's say he's made 21 of them. Okay? So he's made 21 of 24 free throws already this season. So he steps to the line for the 25th time. I'd probably say the probability that that's going in is what out of what? 21 out of 24, based on what he's already done or what's already happened.
I
Okay?
just said that.
All right? Okay? And then the last one that's tricky for kids. It always has been, and I'm not sure why, but it's always called odds. Okay? There's two kinds of odds. There's odds for and odds against something happening. Okay? It says the odds of an event compare the number of favorable and what? Unfavorable when all outcomes are equally likely. Okay? All right. So let's say this. Let's say, well, the record of a team is 4 wins and 2 losses. Okay, based on what's already happened, what are the odds they win their next game? What? 4 to 2. Okay, the odds for winning, they've got 4 successes and 2 failures. So 4 to 2. What if I turn that around and say, what are the odds against winning? 2 to 4. Okay. Now some of you might think 4 to 2 or 2 to 4. Those can be written in fraction form. So could 4 to 2 be changed to something in simpler form? 2 to 1, right? Or the odds against, instead of 2 to 4, you might say 1 to 2. Right? All right, so vocab-wise, up here for odds, there's 2 types of odds. There's odds for, there's odds for something happening, and there's also odds against something happening. And we'll look at some examples here that deal with that, okay? So vocab-wise, I don't think there's anything in there that's too new for you. But again, if you struggle with vocab, where can you look? Yeah. Okay. Key question? Okay. All right. Let's talk example 1. You spin a spinner and flip a coin. Let me get a spinner and a coin. Hang on a second. This will be fun.
Spinner?
Huh?
Fidget spinner?
I got a sticker of one of those.
No, I put spinners on my truck.
Those are stupid.
No, they're cool. When my kids were born in the stroller, I had spinners on their stroller.
Why?
Had a bumping system on the little milk rack. It was cool. Thing would bounce.
You believe them, seriously.
You know what? That actually could be a thing. That could be our $1 million invention, guys. We could make baby stroller spinners.
No.
That gives
I bet it would sell.
What he said, shaky
Let's
baby
use the
sitter.
I don't want to be known for that.
You can use the money to scout the grant.
Yeah.
This is true. Don't tell your dad you said that. Okay, I need to get a spinner here. Let's do this.
Let's use one of those things.
Use this math book.
Yeah. Did you guys return your math book?
I
Carson didn't want it, he said.
I don't want it.
Let's give it back.
Just hang on to it for now. We'll figure something out,
We got
okay?
math books?
So,
Did you guys return yours?
We did.
I put,
We didn't?
I gave him my.
We did.
Okay, kids, here we go. Let's just talk about this right here. It says you spin this spinner. How many outcomes are on this spinner? 4. And you flip a coin. It says how many possible outcomes are there in the sample space? And then it says list the possible outcomes. Okay. Well, kids, how many opportunities are here?
4.
4. So if I spin this, I say, well, there you go. Spin the thing. All right.
Fancy.
That's fake news.
Just like everything else.
Is that
Make-
blue or purple?
Make sure you rake your yard so your house doesn't burn down. Okay.
Yeah, we rake it like Finland.
Anyway,
That's what he said. Yeah, good.
it says list the possible outcomes. So the first thing we're doing is spinning a spinner, right?
Rake your
And then the next thing you're going to do is what?
Flip the
Flip a coin. It says
What's the
right
other
here
side
for
of that?
what's that?
There's a 1 and
But
what's
it's
on the
a
other
2.
side?
yes, yes, yes.
That's a tails. This is the other one is
That's
heads. Okay.
so
All right, so that's just the way that they do it. Okay, so real quickly, kids, here's what I want. Make that a little smaller so I have some room to write. Oops.
careful.
Are we supposed to draw this?
Nope. So right here, kids, the colors that we have up here for outcomes are red, white, blue, and green, right? Okay. And then it says how many possible outcomes are in the sample space. So we spin the spinner once, and then we flip a coin. How many outcomes are there in the spinner?
4.
4, and then how many outcomes in the coin?
2.
So if I'm putting these together or combining these situations, it wants to write a sample space for the possible outcomes, okay? So with this right here, kids, we could have, let's go spinner first. Our outcomes, we could have red and heads, right? You guys agree with that? Or we could have red and what? tails. Okay. What are some other possible combinations here? Blue and tails. I'll put maybe a BT here. And then blue and what? Okay. What other combinations could I have?
Green.
Green
Heads.
heads or green tails. And then what's the last possibility?
White.
White.
White heads or white tails?
White heads. That's kind of gross. All right. Or white tails. Okay. So the question in this right here, you spin that spinner, and on that spinner there are how many likely or equally likely outcomes there? 4. And how many equally like comes or outcomes on the 2? So what's 4 times 2 make?
8.
All right. So right here, here's the list of the possible outcomes. How many possible combinations did we get? Looks like we had 8 of them right here. So guys, what's the relationship between 4 and 2 to get to that 8?
We love to shoot white tails.
Okay. There's 8 possible outcomes, right? This here is considered your sample space. The listing here is considered your sample space. The number of outcomes here then, kids, was how many? What if I had a spinner that looked like this? Maybe that's my spinner, okay?
No, not a lot.
How many outcomes would be in the sample space there if I said spin and flip?
16.
16, because there's 8 colors up there. And,
There's 2 possible outcomes.
yep, so 8 times 2 would be 16.
Three-sided coin.
Okay.
A 3-sided coin? I don't know. How do you do that?
There's not.
Okay, so let's talk real quickly. It says a coin is flipped how many times, kids?
4.
It says what's the probability that it lands on heads exactly
Triangle is
3 times? Ooh, this is a tough one. Okay, here's the deal. How many outcomes on the first flip? How many possible outcomes on the first flip? 2. How many possible outcomes on the second flip?
2.
How many on the third? How many times is this getting flipped?
4.
4. How many possible outcomes on the last one?
2.
So if I go 2 times 2,
4.
times 2 more, times 2 more, how many
16.
possibilities do we have? It says right here, what's the probability that it lands on heads exactly what?
3 times.
Oh boy, here's what I'm going to do, kids. We're going to create a sample space for this, all right? We know that our sample space is going to consist of how many possibilities? 16. So let's make a chart kind of like this. Let's go maybe a horizontal line here, and then I'm going to make 7 of these. 1, 2, 3, 4, 5, 6. Oh, Parson, you kind of screwed up, but that's okay. I can fix it. 7. Let's do it this way.
I don't know.
Okay, let's just start out with this right here, kids. I'm going to say up here every time heads. I'm just going to say the first one could be heads, 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 heads. Is that okay?
Why is there so many heads?
Because maybe it landed heads 4 times in a row. Right?
Yeah.
So then maybe this next one goes heads, 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 tails. Okay. Ooh, wait a minute. How many heads are there exactly there? 3.
That's
What are the possible ways? What are the possible ways that I could list my flips where heads appears 3 times? Exactly 3 times.
Right there.
Well, couldn't it go heads, heads, tails, heads then next? That's a possible outcome, isn't it? Okay.
What could be tails, heads, heads.
Could it be, based on what I'm doing right here, what could be the next one?
Heads, tails, heads.
Heads, tails, heads, heads. Okay, what's another way to have exactly 3 heads?
Tails, heads, heads.
Tails, heads, heads, heads.
Only flip 3 times.
Exactly 3 times. Is there any other way for me to write a combination of flips down other than this one, this one, this one, and this one that shows up heads 3 different times? Exactly 3 times. Okay, now that word exactly is important. Okay, because if it would have said that it lands on heads 3 times could mean 3 times or what? Okay, so that word exactly is a big deal. Kids, do I need to list the other combinations out if I know?
No.
Because how many outcomes do we already know we're going to have?
It's 4 out of 16.
16. So there's what's the chance that we're going to end up with heads how many times? Exactly
4.
3. We know that there's 16 outcomes, the way the order of coins could land. And of those 16 possible outcomes, the only way I get exactly 3 heads is this way, this way, this way, or this way. Unless you guys can think of another way to list 3 heads and a tail. Can you think of any other way? No. So the probability here is 4 out of 16. Or you might call this 1/4. Or some people might say, let's call it a decimal of 0.25. Or you might call that what percent?
25%.
Okay, let me ask a question. Impossible, not likely, likely, or certainly happening?
Not likely.
Not likely to happen, but there's a 25% chance that it could happen that way.
For 70%.
Okay. Do you guys want me to list the rest of the sample spaces, or do you understand why I'm going to leave the rest blank?
75.
It's fine.
It's fine, Audrey? Again, why do we know that there's 16 possible ways this can land? Well, we took 2 times itself. How many times did we flip?
So how do you get the 16?
Okay, we're at the 16 possible outcomes. First outcome, how many outcomes are there? First flip, how many outcomes? 2. Second flip, 2 times 2 more outcomes is 4. Third flip, times 2. The 4 turns into an
Oh, you're
8.
multiplying.
And then the 4th flip times 2 again. You just keep multiplying by 2. Okay? So if we went a 5th flip, how many possible ways could those order up? 16 times 2 more would be 32 different ways. Okay? So let's talk here, kids. Finding probabilities of complements. Ooh, I like this problem.
Exponent thing, isn't it?
What's that?
It's like you would use an exponent.
Starts becoming exponential, and that's kind of like why the probability or the odds of winning lotteries is so high, because I mean you can get the first number right, but after that your chances dwindle for each one after that. When you start taking 50 possible outcomes times 49 on the next ball times 48 on the next one, then boy, it gets to be crazy after that.
I'm gonna
Okay,
win it. I
I wanted that $1 billion one. I was waiting for that. You were all going to get money from me if I won that. Yep. Okay. Find the probability of each event when 2 what, kids? Okay, I think we should do this, kids. I think we should make a little chart down at the bottom. So let's make a little chart down here. I'm gonna number like this: 1, 2, 3, 4, 5, and 6. And I don't know if I'm gonna be able to squeeze that in down here. Gosh, let me do this. Let me blow this up here quick. Boom!
Oh!
Over here on the side, if you can squeeze it in here, go 1, 2, 3. Gosh dang it, Parson. Okay, 1, 2, 3, 4, 5, 6, like that.
Oh, it's like a multiplication.
Okay. Now, if I was making a chart right here, kids, and I should have put this on here for you, and I didn't, so I apologize for that. But, kids, if I roll 2 6-sided die right here, maybe I have 2 of them up here. Well, I do. How many outcomes are there on this first die? 6. How many on the second one? 6. Okay.
Those are 6. Oh yeah, the normal one's 6.
So it says right here, kids, what's the probability that the sum is going to be greater than what? 8. Okay. Well, what we would probably need to do is make a chart here, and I'm going to put it off to the side here to sum up some values. We've got 1, 2, 3, 6, and 1, 2, 3.
Does it have to be greater or equal to?
It says greater than 8. It doesn't say equal to 8. It says greater than 8.
So 9 or above?
Okay. How many sample spaces are there? Or in other words, how many possible outcomes, if you will?
36.
Careful. 6 times 6 would be...
36.
Okay, so if I started to make sums right here, kids, if I rolled a 1 and a 1, what would the sum be?
1.
Ooh, careful. 2. 1 and 2 would be 3, 4. I'm going to do this real quickly. You don't need to write this down.
This is a lot of numbers.
Okay, this is going to get goofy.
Maybe I will. What about it?
Okay, quick question, kids. My P is going to be in the way, but this would be 7, 8, 9, 10, 11, right? And then 8, 9, 10, 11, 12 over here. Says, what's the probability we're greater than what, kids? 8. How many are down here are greater than 8? 11, 12. There'd be 4 in that bottom row, right? How many are greater than 8 here?
3.
How many are greater than 8 here?
2.
How many are greater than 8 here?
1.
1. So 4 plus 3 plus 2 plus 1 is how much?
13.
Careful. 4 plus 3 plus 2 plus 1.
11. 4 plus 3 is 2. 7.
I can't
plus
do math.
2 is 9. 10.
10, right? Okay.
Wow, that took a long
So
time.
if you summed all these up, and I know I'm goofy, I'm kind of overlapping here, but do you understand where these numbers are coming from?
Yeah.
I get a 1, I roll a 1 and a 1. What's the sum, kids?
2.
I roll a 2 first and then a 1 second. What's the sum?
3.
Okay, all these sum possibilities, how many are more than 8? Greater than 8. Well, there's 1, 2, 3, 4 in this bottom row. 9, 10, 11 in this next. 9 and 10, and then the 9. Okay? So there's 10 numbers that are greater than, or sorry, 10 sums that are greater than 8 here. So the probability is 10 over 36. Some of you might choose to reduce this to 5 over 18. Some of you might say, gosh, let's turn that into a decimal and divide that out. Okay? I don't care what you do. All right? But understand how to get this. Okay? Next one's pretty interesting. It's called using complements. If there's a 10% chance of something happening, what's the chance it won't happen?
90.
90%. You just take that and subtract it from 100%. Okay? Or if there's a 1/5 chance that something will happen, what's the chance that it won't happen? 4 out of 5. Okay? Well, kids, how many outcomes were up there on that sum table?
36.
36. The next one says the sum is what?
Not 2.
Okay, this word not is important. It's like saying let's look and see what the probability would be if the sum was 2. How many 2's show up in that chart up there?
1.
It happens one time. Meaning there's a 1 in 36 chance that you'll get a sum of 2. So what's the probability or the chances that you will not get a 2?
35 out of 36.
35 out of 36. We could say, well, this is like taking 1 minus the 1 out of 36. But 1 is like 36 over 36, isn't it, kids?
Yep.
So the probability that we do not get a 2 is,
35 out.
okay? If somebody walked up to you and said, I'm going to give you $1 million to not roll a 2,
I'd probably roll a 2.
probably would. But they say, if you lose, you have to give me a bag of Sour Patch Kids. How many are going to go ahead and take that bet?
That's a good bet.
That's a pretty safe bet, isn't it? Because
I want to start.
now what if I walked up to you and said, hey, you're going to pay me $100. You're going to pay me $100 if you roll a something. What if I walked up and said, listen, I'm going to pay you $1 million to roll a 2, but you have to pay me $100 if you don't roll a 2.
I do it.
I'd roll it 36 times and hopefully get 2.
I don't think that's how it works.
God help us all.
And if we pay $100.
Maybe you should
Yeah.
just roll it
You have to
70
pay them
times.
$3,600. You get $1 million.
Somebody take $1 million divided by 36.
Yeah, I got this. Go on your phone, Adam.
Mr. Geisman would know this.
You'll still be so profitable.
Yeah, you just
36.
so hard not to
No,
know.
1 million divided by
Can you
36.
count that?
Unless you
How many zeros is that?
This is how many times you multiply.
1, 2, 3, 6-0.
Oh my
That's
God.
6-0.
27,777.777.
So here's the
Too
deal.
bad it wasn't 75.
I walk up to you and I say, hey, you pay me $30,000 if you don't roll a 2. I'll give you $1 million if you do roll a 2.
You still do it.
I would not do that.
Hey.
He's like, hey, this is Vegas.
All right.
Wait, no, you wouldn't. You would lose money because it's 27. It's the
Yeah.
I'm just gonna send it.
Chances aren't good. Okay, let's roll. Next page. Any questions about what we're doing up here?
Yeah.
Guys feeling okay so far?
Yeah.
Okay, next page. All right, let's talk. Example 4 says talking about finding an experimental probability, and I really like this problem right here. It says a spinner has 5 sections colored red, green, blue, yellow, and purple. Each section of the spinner has the same area, meaning the outcomes are equally likely if I spin this. It says the table shows the results of how many spins. Now think about this. How many colors are up there, kids? 5. How many times are you spinning the spinner? If each sector is the same size and the outcomes or the probability of an outcome is equally likely for each color, how many times would you expect the spinner to
10.
stop on each color? 10 times. 50 divided by 5. That's what we expect, 10 times. But is that always going to happen? No.
Because the world's not round.
Okay, it says for which color is the experimental probability of stopping on the color the same as a theoretical? Theoretically, we said, well, Carson, if there's 5 colors and we spin 50 times, each one should get 10. Which color followed the theoretical rules?
yellow.
Yellow. Okay, all right. So it says for which color is the experimental probability the same as the theoretical? Theoretically, there should be a 1 in 5 chance of stopping on any color, right? Okay, but we spun the spinner how many times? Okay, the experimental probability for yellow was, how many times did it stop on yellow? 10 out of 50, which is the same as a theoretical of 1/5. So which color was this good for? It was good for yellow, right? Okay. Which colors went above theoretical? Which colors were better?
Purple and green.
Purple and green. Which color had the least likelihood of happening?
Blue.
If you went with this chart right here, what color, if I said $1 million, kids, what color are you going to pick to land on?
Green.
Why green? Based on what happened, that's the one that occurred most frequently, right?
Now, concluding that the spinner is in good condition.
Never know. Maybe there's... Ooh, do you think people would do that? Fix a game to...
Yeah.
Probably.
Yeah. Me?
Fixing a game so you win.
That's what they're
Hurry. Okay. All right. Hey, here's the deal. It says use the survey and data display in example 5. We're going to use this data up here. Okay, what is the probability? Oh, I need to get you to a page. Hang on a second. I need you guys. Do you guys have your books with you or not?
Sadly, we do.
Oh, okay.
I do not.
Don't worry about it. I'll pull the page here quickly. Who does have their book? One person for me.
Well, I can get mine. It's right there.
There we go.
Okay, what I would like you guys to do is to go to chapter 5.
Are we supposed to capture our books?
You know, I'm not too worried about it because your book is really in Big Ideas. So if you want a book, take it. If you don't want a book, I'm going to tell you don't have to have it.
That'd be good fire star material.
Ease down, Michael.
Oh, Mike's a man.
Tread lightly.
No, to Cat Monkey. That was worse.
They were all bad.
Okay, let me get to example 5 right here. All right, right here, kids. Example 5. Here we go. Let me zoom this up a bit. Can you guys see this chart okay right here with pets? says in the United States, a survey of 2,184 adults ages 18 and I don't know have at least one pet. The type of pets were in the table. Okay. How many total adults were surveyed here?
2,180.
2,184. Would you guys take a look at your example 5? What does example 5 say?
Example, what?
The
Where is
survey
it?
of data is
Solving a real life problem.
I see example 4.
Okay, so there's 2,184 people.
93 out.
Yeah, how many people own a bird here, kids?
93.
93 out of 2,184. So that chart is there in your book. Okay, that's pretty simple, wasn't it?
Yes, sir.
Okay, so we're going to call this 93 out of 2,000. Yeah. 93 out of 2,184. Now, what I might choose to do is this. I'm not really the best at simplifying fractions, so I don't really want to. Simplify that. What I would tell you is this. Maybe we should turn this into a decimal or a.
What about a decimal as a fraction?
Well, you don't have
Yeah, percent is the same as decimal pretty much.
Yeah, decimal into a percent. I'm going to go 93 divided by 2,184. This is what I get. So it's going to be about 0.04. Maybe I call it about 4 point. I like to go 2 places on stuff. So this would be about 4.2, probably round 5 up to what? 6, wouldn't you? So this is going to be about 4.26%. So guys, in that chart of animal owners, if I picked one person at random, likely or unlikely that we're going to pick someone that has a bird?
Unlikely.
Pretty unlikely. There's only 4.26% chance.
Unless
Okay?
they look like a bird guy. That's easy to tell.
Yeah, you look like a bird guy.
Okay, here we go. Finding odds. Let's talk. It says use the table in example what, kids? This is where things get goofy. Odds against and odds for. I'm going to put a definition for odds against and odds for. Okay? Odds against. The definition of odds against is the number of unfavorable. Whoops, can't spell today. I'll make that an A.
None of us would notice it.
Unfavorable over favorable. Okay. Anybody want to guess what the odds for definition is? If odds against is unfavorable over favorable, the odds for is probably favorable over unfavorable. What are we after in this case right here, kids? Odds against stopping on what color? Okay, this is based on this chart up top here. How many spins did we take totally up here?
50.
Of the 50 spins, how many were blue?
3.
Blue was the event we're talking about. That's the favorable that we want to talk about. So, how many up here were favorable? If 3 of them were favorable, of the 50 spins, how many were unfavorable then? So the odds against blue would be 47 to what? Let me ask this question. What would the odds for happening be? 3 to 47. Okay, the odds for it is 3 to 47. What this means, kids, is this. It means for every 3 times it stopped on blue, there was 47 times that it didn't stop on blue. Okay? What ratio would give you a 50% chance? What 1/2 is 50%, right?
Yes, sir.
What are the odds when something's 50%? Either it is going to happen or
It's not gonna
it's like flipping a coin. What are the odds of getting heads? Well, how many sides are heads? 1. How many are not heads? 1 to 1.
That's right.
Okay?
That's a ratio.
All right. All right. Any questions so far? Last example, and I'll get you out of here. I am going to send out an online page for 5.1 here, but it won't be due until the Tuesday when you get back. So be checking in big ideas when that comes out. Okay. Makes sense? Okay. I like this question. It says the probability of winning a balloon dart game is what?
2 to 7.
Okay. I'm going to highlight something. This is a what? But then they turn around and say, oh, by the way, the odds of winning a ring toss game are what? All right. It says which game gives you the better chance of winning, okay? When you're comparing probability and odds, turn stuff into a percent. Now, probability is already here. Our probability is what, kids?
25%.
This is 25%. Now, we need to be careful with odds, okay? The odds part, turning odds to a probability, this gets goofy. But it's really not. What are the odds of winning the ring toss? Well, it says 2 to 7, right? Okay. Basically, you play the game, and every time you play the game, there's... How many games would you have to play to win 2 games? Be favorable. This is like winning 2 and not winning.
9.
You'd have to play 3.5.
There's really how many games right here? This is the chance for winning, and this is the chance for losing. Okay? So this is really 2 out of what? 9. Okay, we'll pick this up. You guys have a great break, okay?
You too.
Will do.
An excellent turkey.
I have to make 4 turkeys on Thursday. I have to fry 4 turkeys.
Hey, can I throw my
Can you what?
Spanish.
can I throw all my health away?
So I
Come to the office. Daddy Bonner. Cameron Pike.